cover in this lecture. So we will only focus on understanding the relationship between the classes, why those classes are created, because each class has a different purpose in this framework. And we will obviously talk about the hierarchy as well. In the upcoming sessions, we will go into the hands-on exercise of some of the most popular collections. We will not be able to provide hands-on of all the collections classes which you can see on the screen, because then it is going to take a very long time to complete this concept. But we will cover the most popular ones or the most used ones out of this particular framework. So let's get started. As you can see, let's first understand some of the symbols here, and let me just zoom this in a bit so that it's visible. Yep, now I have just increased the resolution a bit. So you can see there are three different symbols or legends here. You see this oval shape which is called interface, so you can see some interfaces here. Then you see this rectangular blue box which is called abstract class, and you can see some of these blue boxes. And then you see the purple box which is called the class, and you see some classes here, these ones. So for now we haven't covered the concept of interfaces and abstract classes, but we will cover that in the coming lectures. And for understanding the collections hierarchy right now, at least the concepts of it, you don't need to be fully aware of the concept of interfaces or abstract classes. So let's dive deeper into the framework. Iterable is basically an interface. To give you a very simple definition of an interface basically is sort of a declaration which will tell you what kind of classes will be present under the interface. For example, if you have to, let's say, store all the cars and all the bikes and all the bicycles and all the trucks from all around the world, then you can create an interface called vehicle and create all of these classes under the interface, and these classes will be about cars, about trucks, and about other kind of vehicles. So an interface is a generic blueprint of specific class implementation. That's a very simple definition of an interface, and like I said, we will go deeper into this concept in the upcoming lectures. So that was about interfaces. Similarly, when we talk about abstract classes, the next legend here, abstract classes are also similar to interfaces, where they provide you a generalization, but at the same time, abstract classes provide you a way to also write some concrete implementation. For example, if we take the example of a bank account, so there in a bank you have different kinds of accounts. You have savings accounts, you have recurring accounts, you have current accounts, and there are many other different types of accounts. So there would be some common implementation and logic which will be applicable to all the account types. For example, an account must have an account holder. That account holder must have a valid KYC done, for example. So there would be some sort of common logic which will be applicable to all of these, right? So that common logic, so you have two options. Either you can write that common logic again and again in the savings account class, in the current account class, in the loan account class, etc., etc., or you can write it at a central place and just refer it from there. So that's where you will use abstract classes. So you will create an abstract class of an account, and then you will create these child classes under this account class, which will be the savings account class, the loan account class, the current account class, etc. So this is a very lightning introduction to you about interfaces and abstract classes. And class, as we know, is basically a concrete blueprint which holds data and logic together. So here iterable is an interface which will just specify that all the kinds of data structure which can be iterated, which can be looped over, should be present under this particular interface. That's why we created this interface. So under iterable we have this collections interface, and this will govern that everything which will present under the collection interface will be holding some sort of a collection of items. Now we look at the next set of interfaces. We see a set interface, we see a list interface, and we see a queue interface. When we talk about the set interface, these three different types of interfaces represent three different properties of collection, and these properties are exclusive of each other. For example, if we talk about set, so set has a property that everything which you put into set will be unique. It will never ever tolerate or contain any duplicate elements. That's the property of set. So now you can see whenever you have a scenario where there is a strict constraint that your collection should never have duplicates, you will use sets. When we talk about lists, list is probably the most lenient representation of a collection. It can store anything. It can store duplicates as well. It will not raise an error or a warning if you store same element multiple times. It will happily store it. But at the same time, the list is basically an index based collection. You can access the elements starting from the index 0 till the last element. That's the basic value proposition. So whenever you have a requirement where you want to access the elements into a predefined sequence and one by one, then you should use list. Also, the order is fixed here. The first element will always come after the zeroth element. The second element will always come after the first element. So whenever you iterate over this particular list, you will never have a scenario where you do not know the order of the elements being accessed. They will always be accessed in a predefined order. So it's basically, we can call it as an indexed ordered collection which can hold duplicates. Then the third one is queue here. So queue is basically, as you can, this is basically inspired from real world. So think of any queue. If you go to buy something at a grocery store, or if you go to buy a ticket at a railway station, or you go to the check-in counter at the airports, so you stand in a queue. And the concept of queue is that it works on a concept of first in, first out. The person who first went into the queue will be the person first being served and coming out of the queue. And if the second person comes, that has to be standing behind the first person. And once the first person is served and goes out of the queue, the second person comes at the front of the queue, and that particular person is served. So you can see, it's if you have to store that kind of behavior, or if you have to implement that kind of behavior in a Java program, then you would use queues. So this was about the top level interfaces, which are set, list, and queue. And out of these, list and set are very popularly used, very heavily used in any kind of Java enterprise grade application. Now there are more interfaces like sorted set, navigable set, and dequeue. Sorted set is basically forcing additional constraint on the set that the elements will be unique. At the same time, you can also have the elements into a sorted order. Sorting can be an incremental sorting or decremental sorting, that depends, but the whole idea is that it will be sorted. Similarly, navigable set brings another navigation kind of properties. DQ is basically a double-ended queue where the elements can be inserted and removed both from the front and from the back. So there are the different properties of these interfaces. But like I said, the most popular ones are these three ones. Now let's talk about the abstract classes. So the abstract classes you see here are abstract collection, abstract set, abstract list, abstract queue, abstract sequential list. Generally, you will not be using these directly. You don't need to use them directly, but you should be aware that they exist. If you have a very specific case where you want to use these abstract classes, you can use them in Java program, but most of the time you don't need to use them, and most of the times you will be dealing with either the interfaces or you will be dealing with the concrete classes. Now this lecture is getting a bit long, so I will like to stop this lecture here. So we covered about the interfaces part of the collection, and we also understood